This is Course 2, Lesson 120, and we will be graphing nonlinear equations. So one way we can graph nonlinear equations is to make a table of ordered pairs, or a function table. And we can plot enough of these points to give us an idea of the path of the curve. So for example 1, we need to graph y equals x squared. So we have y equals x squared. So this equation that we see here, this is like the formula for the area of a square, except we have y and x. So y and x are just replaced by a and s. So this is a and this is s. So we have area equals a side squared. So our first step here is we need to make a table of ordered pairs. So what we want to do is think of numbers for x, and then we'll plug them in to the equation and then calculate y. And then we will also replace x with negative numbers as well, because since we have this formula here that is squaring the x, we have to remember that squaring a negative number results in a positive number. So if we start making our table of ordered pairs, we have x, y, so you generally want to start with simple numbers. So we will start with 0, 1, 2, and 3. So when we plug 0 as x into here, we know that 0 squared gives us 0. So our first ordered pair is 0, 0. When we plug 1 into this formula, 1 squared, we know is 1. So we have 1, 1. When we take 2 and we plug it into our formula, we know that 2 squared gives us 4. And then lastly, we take 3, we plug it in up here, we know that 3 squared gives us 9. So we also want to do this with negative numbers. So I will do that over here, a little bit smaller. So we can't do 0, but we will do -1, -2, and -3. So once we plug -1 into here, we know that -1 squared, we are basically just ignoring this negative sign, so we get 1. We know that -2 squared, we get 4. And same thing for -3, we square it, we get 9. So our ordered pairs for this one is -1, 1, -2, 4, and -3, 9. So now after generating these several pairs of coordinates, we want to graph the points on a coordinate plane. Alright, so I rewrote everything to make it look a little nicer. So once we have figured out our ordered pairs, we want to plot them. So we have 0, 0 plotted here. That is our origin. So we'll go 1, 1. We will do 2, 4, 3, 9. Then we'll go over to the negatives. We have -1, 1. We have -2, 4. And we have -3, 9. So now we will connect all of these. And obviously if you have graph paper, it will look much nicer and much more smooth. So we see here that this is the shape of our curve for our equation y equals x squared, and we get a nice parabola here. So for example 2, we need to graph y equals 6 over x. So the same way that we started example 1, we need to start this problem. So we need to come up with our table of ordered pairs. So just for convenience, we want to pick x values that are factors of 6. And we also want to remember to make our negative values as well. We also have to note that we cannot pick 0 as an x value because since x is here in the denominator, we know that we cannot divide anything by 0 because 0 is undefined. So we will start figuring out our coordinates. So we will do, and remember we want factors of 6. So we will do 1, 2, 3, and 6. And then we want to remember to do our negative values as well. So we'll do the same numbers, just negative. So we have -1, -2, -3, and -6. So we'll plug 1 into x here. We get 6 divided by 1 is 6. So we get coordinates of 1, 6. Same thing for 2. 6 divided by 2, we get 3. 2 over 3. 3, 6 divided by 3 is 2. 3, 2. And then 6 divided by 6 is 1, so we get 6, 1. So we'll move over here to our negative values. So 6 divided by -1 will be -6. 6 divided by -2 will be -3. 6 divided by -3 will be -2. And 6 divided by -6 will be -1 for our last coordinate. So now we want to plot all of these. So we will plot them onto our coordinate plane, and obviously yours will look a lot nicer because I'm not doing this on graph paper. So our first coordinate we will plot is 1, 6. The next one is 2, 3. The next is 3, 2. And the last is 6, 1. We move over to our negative values. We have -1, -6. We have -2, -3. We have -3, -2. And we have -6, -1. So we can already tell that these two curves are not going to intersect. So we can connect them with our, what should be a smooth line, which might not be. All right, and we have our final answer.